Today we look at matrix exponentiation. In the first case, we have a simple example of raising a scalar to the power of a matrix. When we do that, what do we get? Well, in this case, we have 2 raised to the power of matrix 1, 3, 2, 4. And we get, as a result, another matrix, which each element of which is a result of raising 2 to the power found within the matrix. So in this case, we get the matrix 2, 8, 4, 16. Okay, so that is an example of raising a scalar to the power of a matrix. How about raising a matrix to a scalar power? And this, again, a simple example. We have a simple example. We have matrix 1, 0, 2, 1 raised to the third power. What that means is that we have this matrix taking, this square matrix taking 3 factors of this matrix. 1, 0, 2, 1, 3 factors of that matrix, of that square matrix. We multiply by itself 3 factors, and what do we get? Well, the result is, for this example, matrix 1, 0, 6, 1. That's by multiplying this matrix times itself, and then another copy again for a total of 3 factors. And you can check this out yourself. Line up 3 factors of that square matrix and carry out the multiplications and see if you get the same result. Okay, so that's a simple case of raising a matrix to a scalar power. How about we raise a matrix to a matrix power? So the matrix is the base, and another matrix is the exponent. And in this case, we will use the matrix 1, 2, 1, 1. We'll raise it to the power of the same matrix. I mean, we could use a different matrix, but in this case, we'll just use the same matrix raised to the power of the matrix. Now, the 2 ways we can go with this. If we, say, put this in parentheses for clarity, then we are raising the entity, the matrix 1, 2, 1, 1, to the exponent 1, 2, 1, 1. In which case, what we're doing is we're raising the matrix to each power, or the individual elements within the exponent matrix. And that result gives us a matrix of 4 matrices, right? Each matrix element, or each element of this matrix is itself a matrix. And we get the results, corresponding results of raising that matrix to each of the powers of the individual elements in the exponentiating exponent matrix. Okay, so this is our result. And what we can do here, right, we have a matrix of matrices as our resultant matrix. What we can do here is we can get rid of the little walls of each individual matrix element and have basically a matrix of greater number of elements. See, if you want, you can take away those parentheses. Okay. Now there's another way, there's another approach here, and that is to raise each element in the base matrix to each exponent in the exponent matrix. And that gives us a different result, because now we're dealing with it's like a set of scalars. We're just giving ourselves, we're just taking a set of scalars and raising each member of that set to power and the matrix that's exponentiating. Okay, so the result in this case, right, we're just listing the results of each individual element raised to each individual power in the exponentiating matrix. And I hope that is clear. You could try this yourself. Take each element in this in the matrix, each element in this matrix here, raise it to each power in this matrix here, and see if you don't get the same result. Okay, that's it.